Hi everyone, in this video we will cover the chapter on fuels and crude oil. We'll look at sources of energy including your fossil fuels and also study how crude oil is separated into useful fractions by the method of fractional distillation. After watching this video, you should be able to explain what it means when we say something is non-renewable, and you should also be able to explain the principle behind the separation of crude oil into the various fractions using fractional distillation. We will see why there's a tension between the various uses for crude oil, either as a fuel or as a feedstock to make other useful materials. So let's begin by understanding what it means when we say something is a fuel. A fuel is a substance that can undergo a chemical reaction. Usually we burn it, and it results in the release of thermal energy. So there is an energy conversion from chemical energy to thermal energy. So if you ask around your grandparents' generation, perhaps if you know anyone who lived in Singapore in that era, you can ask them what were the fuels they used in the past. Nowadays, all we need to do is to turn on the switch and we can have lights at home, but in the past, that's not the case. So you would probably see kerosene lamps where, literally people are burning the midnight oil. In Singapore, the energy that we get is largely derived from fossil fuels. So in the power plants, these fuels are being burnt and then they are converted to other forms of energy, and then therefore you have electricity that runs through your power grid. In the past, Singapore used to have coal-fired power plants, but nowadays the main source of energy is liquefied natural gas. Okay, that accounts for 95%, and we get most of it from Malaysia. There are also other sources of energy that Singapore uses, and solar energy being one of the more recent developments. So let's take a look at this video which shares with us the Singapore energy story.
So,
Singapore's energy story.
yep,
Do you know anything about it?
nope.
Hey guys! What is the long faces?
This science project is so tough.
Talking about Singapore's energy story is pretty simple, really.
Really?
Really?
We're a small country, which means we have some restrictions when it comes to producing energy. We don't have a lot of land, we have no natural resources, so we have to import all our fuel, and we cannot implement some renewable energies because of geographical constraints. The good news is that Singapore is not letting these problems stop us. Take the SLNG terminal, for example. Did you know that 95% of our electricity is generated using natural gas? The establishment of the SLNG terminal allows us to import liquefied natural gas from all over the world. Previously, we could only depend on piped natural gas from Malaysia and Indonesia. The natural gas we import is mainly used by power generation companies to generate electricity. Let's find out more.
Hello, this is the combined cycle gas turbine, which uses both gas and steam turbines to produce more electricity from the same fuel as compared to steam turbines. It converts chemical energy from the natural gas to kinetic energy of the turbine. This kinetic energy is then converted to electrical energy via a generator.
This technology is so cool.
Cool, right? Wait till you learn about solar energy.
Oh yeah, Singapore's a tropical country. Can't we harness solar energy?
Let's ask an expert. Hi guys!
Well, to answer your question, Singapore is actually open to exploring all types of fuel sources and technologies such as solar, and right now, the most viable source of renewable energy is solar energy. Come, let me show you. However, solar energy is dependent on whether we have clear blue skies. If there's cloud cover, the supply will be intermittent. On average, we only get 5 hours of sunlight.
So if Singapore relies solely on solar power, I can't switch on the lights to study at night?
Actually, even if we cover all of Singapore with solar panels, we are still unable to meet all of Singapore's energy needs. That's why we need something more reliable like natural gas to generate electricity.
But we can use batteries to store the electricity generated from solar panels, right?
Yes, but Singapore's hot and humid climate affects battery performance, which is why further research is required. We are also improving solar forecasting as the information will help us make better use of solar energy.
So, Singapore needs electricity 24 hours a day, every day.
Yes, and luckily for us, Singapore has one of the most reliable energy grids in the world. Compared to other major cities, Singapore experiences less than 1 minute of disruption per customer per year.
We've seen how electricity is generated, but how is it sent to our homes and schools?
Come to think of it, I've never seen any overhead electricity cables in Singapore.
That's because they're right under us. Singapore has limited land, so we shifted our cables underground.
Yes, did you guys know that much of Singapore's transmission and distribution network are all underground? It's made possible by clever engineering and advancements in technology. Apart from cables, Singapore also has other underground infrastructure such as the Singapore District Cooling System under Marina Bay. It provides chilled water for air conditioning to buildings such as Marina Bay Sands. This also frees up space above ground for other exciting users such as the infinity pool.
Cool!
Yeah, the Singapore energy story gets cooler the more I learn about it.
Do you know what else is cool? We use the condition monitoring system to predict and avert downtime and disruption, hence allowing better allocation of resources. We also use smart meters to tell consumers how much electricity they are using so they can adjust their energy use and save money.
So the secret to our power system's reliability and efficiency is good old-fashioned hard work and cutting-edge technology.
The stuff you guys do is so cool. I want to be an engineer in the power industry when I'm older.
Yeah, me too.
See you around, future colleague. So, to sum up, Singapore has transformed its vulnerabilities into opportunities.
And all our energy decisions are based on the energy trilemma, where we always try to balance between energy security, price competitiveness, and environmental sustainability. Thank you.
So over here you see three types of fossil fuels. The first would be crude oil, or what we used to call petroleum, and natural gas as well as coal. Inside crude oil you will find molecules known as hydrocarbons, which consists of both carbon and hydrogen atoms only in the molecule. So given it's a mixture, there's a need to separate it before we make use of it. Then over on the other end we have coal, which is largely just carbon. So you need to know, very important, that natural gas is mainly methane. That is the main component. And when methane burns, you get carbon dioxide and steam. Let's start by understanding where in the first place these fossil fuels actually come from. So fossil fuels are what we call non-renewable. That means once we use it, it takes a very, very long time for them to be replaced again. So it cannot keep up with our rates of use. So by the word fossil means very, very long time ago. Plants and animals, when they die, they sink to the bottom. So the heat from the earth and the pressure acted on these remains of the living organisms and then created the fossil fuels. So they are normally found buried underneath the ground. That's why when we want to obtain like crude oil, for example, you need to drill deep into the earth crust to go and extract it. So first and foremost, let us talk about the difference between coal and charcoal. So coal is a fossil fuel while charcoal is not. Interestingly, I have a sample of coal over here. Okay. So coal is actually a mineral which composed mainly of carbon. Okay, and this used to be the remains of some living organisms who lived millions of years ago. Charcoal, on the other hand, the one that you use for barbecue, is actually derived from your tree. So it's actually wood. And they take the wood, they heat it until it removes all the moisture such that you can use it for your barbecue. Coal is actually obtained from your coal mining, okay, something like this. And it's a very hazardous occupation to be a coal miner. So increasingly, we are trying to find alternative sources of energy. Then we go on to crude oil. Crude oil is a very dark colored, viscous, thick liquid that looks something like this. So by itself, it's not very useful, and we will need to separate it and treat it before we have useful products. Okay, so crude oil is extracted by drilling down through the oil rig and extracting the liquid out using a pump. It looks something like this. And finally, for natural gas, right? Relatively speaking, natural gas in comparison to the other fossil fuels, clean, doesn't produce harmful pollutants. And also, in comparison to coal, when you burn natural gas, the amount of carbon dioxide you get for the same amount of energy produced is less. Okay, so in terms of the carbon footprint, it is better, although not zero. Natural gas is extracted by this method known as fracking. They actually go underground, take a fluid and blast it through, creating fractures. And there are some consequences of doing this. You can go and read up about it, why it may not be very desirable to do so. So natural gas by itself is odorless, but if you turn on the gas stove, you will probably smell something. It's because there is this additive known as tetrahydrothiophene, which is added to it so that in the event of a gas leak, we know what has happened. Normally, when you transport natural gas, it is liquefied first to make it easier to transport. Also, transporting it as a liquid compared to a gas is much safer. In this chapter, we're going to focus a little bit more on crude oil and how it is being separated. And you probably know that Singapore is one of the leading energy and chemical hubs. We are quite famous in terms of the refining of crude oil. But increasingly, given the global stance on environmental issues, there is a pressing need for us to find alternative and greener and cleaner sources of energy. This graph shows you the percentage by mass of different elements present in crude oil. You can see that the majority is carbon. There are also other elements such as sulfur. And compounds in crude oil containing sulfur are often removed during the refining of crude oil. Can you think of a reason why? So when compounds containing sulfur are burnt, sulfur dioxide gas is produced. Sulfur dioxide in itself is an atmospheric pollutant and it results in the formation of acid rain. In the refining of crude oil, there are a few stages, and fractional distillation, which is what we will study, is one of the first stages in the refining process. If you look at Jurong Island, it's filled with many petrochemical facilities. The first step of the refining process is to turn crude oil into a vapor first by heating it. And the vapor is fed into a fractionating column, which is a very tall tower here. And as they rise up, they cool down. So the higher up you go, the cooler it is. So they are separated according to the boiling point. So the smaller and lighter fractions, which have a lower boiling point, will condense higher up. And the heavier fractions like diesel, lubricating oil, and bitumen, they are collected at the bottom of the column. This allows the crude oil to be separated according to the differences in the boiling point. Another stage in the refining process is known as cracking, where the larger and longer chain hydrocarbons are broken down into shorter chain hydrocarbons. Another process involves isomerization, where you rearrange the molecular structure of the compounds. And finally, compounds containing sulfur and impurities are removed. So this infographic summarizes the steps it takes to separate crude oil into its fractions using fractional distillation. So the crude oil is heated into a vapor and then pumped into a fractionating column here. As you go higher up in the column, it gets cooler. The vapor is forced to pass through these bubble caps, and the bubble caps provide a larger surface area for the vapors to condense on. So the smaller hydrocarbons with the lowest range of boiling point, they are collected here on top, whereas the bigger hydrocarbons with a higher range of boiling points are collected at the lower sections of the column. So the temperature gradient in the column allows the fractions to be collected at different heights along the column. By doing so, at each level, you get a fraction, and a fraction itself is still a mixture of compounds but a narrower range in terms of the number of carbon atoms. For example, petroleum gas has about 1 to 4 carbon atoms. They are commonly used as a fuel for heating and cooking. In the petrol fraction, you get molecules such as octane, which is used as a fuel in cars. Naphtha is known for its use as a chemical feedstock. Kerosene is used as a fuel in aircraft. Diesel as a fuel for larger vehicles. Lubricating oil in the manufacture of waxes and polishes, and bitumen for paving of road surfaces. So each fraction has a different use, and now crude oil is much more useful when you separate it into its fractions. Given that you have studied the laboratory method of fractional distillation shown on the left here, and also the industrial method, can you pause the video and think about what are some of the similarities and differences between both methods? Let's talk about the similarities first. So both methods work on the principle of separation based on the difference in boiling point. Secondly, processes involving condensation and vaporization are taking place in both cases. There are many other differences between the two methods. Firstly, in the laboratory method, when you heat the mixture, you always heat it, let's say, from room temperature. And then as the temperature rises, the moment it hits the boiling point, then that component turns into a vapor. It is one after the other according to the boiling point. Whereas in the industrial method, you vaporize the whole mixture and then you selectively condense them at different heights along the column. So that is one of the key differences between the lab method and the industrial method. Secondly, your fractionating column in your lab method has glass beads to increase the surface area, but in the industrial method you don't have that glass beads, but instead uses trays of bubble caps for the vapors to condense on. Then finally, there is only one outlet for the lab method. The distillate passes through one channel only, and every time you have a new distillate, you have to change the conical flask. Whereas for the industrial method, all the fractions are collected at the same time along all the levels. When we evaluate energy sources, we think about the following factors: cost, for example, availability, practicality, and competing uses. For example, if you want to talk about wind energy, Singapore, we may not be so blessed with strong winds. Secondly, we think about how long it can last, whether it's a renewable source or not, and we learn that fossil fuels are non-renewable sources of energy. Thirdly, we think about the impact on global warming. For example, burning of fossil fuels releases carbon dioxide, which is a greenhouse gas that traps heat, and therefore it may worsen global warming. And finally, we think about the impact on the air quality of the environment. So whether or not burning of this fuel results in the production of any air pollutants. Pertaining to crude oil itself is finite. It cannot be replaced quickly enough to keep up with our rate of use. So we say that it is non-renewable. On top of that, we use crude oil largely as a fuel. That means we burn it away, 90% of it, in fact. But crude oil itself is very useful because it provides us with starting materials to make many other chemicals, like plastics, rubber, for example. And in fact, only 10% goes into this supply chain. So if we were to use the crude oil fractions as a fuel, then we kind of limit ourselves in terms of the supply of these other molecules for other uses. So it might be a good idea to think about alternative sources of energy, given that crude oil is a non-renewable resource. Burning of fossil fuels are also associated with air pollution when they release gases such as sulfur dioxide or carbon monoxide. And as I've mentioned, carbon dioxide gas, which is a greenhouse gas, is also produced when we burn fossil fuels. To conserve crude oil, perhaps take public transport to reduce the number of cars on the road. We can look for alternative sources of energy, and we'll in particular look at the use of biofuels. And finally, we can improve in terms of efficiency. One example is the use of electric vehicles. In the next lesson, we'll take a look at biofuels as an alternative source of energy. That's all for this video.